We are going to look at properties of real numbers. So I've gone ahead and I've written everything. Here are some properties that we will be using a lot of for the rest of the semester. Okay, so the very first one that we have on here is associative. It's in dark blue. What it says and what it means is that when adding or multiplying, order does not matter. Now, if you notice that first example, in parentheses, we have A plus B, and then added to that, we have plus C. That is the same thing as saying, I left off my parenthesis. That is the same thing as saying A plus, and then in parentheses, it being B plus C. When I think of associative, I think of associates, I think of friends, I think of groups, I think of the fact that you have more than one friend, you have your friend group at school, you have your friend group at work, and the fact that those groups can change makes me think of associative. It's okay if in the left-hand side of that equation, my A plus B is grouped together. And then on the right-hand side of that equation, my B plus C is grouped together. Because it's all addition, my groups can change. Those parentheses can move, and it doesn't matter because order doesn't matter. And then also for multiplication, if you do A times B first in parentheses and then multiply it by C, it's the same exact thing as doing B times C first in parentheses and then multiplying it by A. So I'm going to do an example of our associative property. Let me see here. Okay, an example of our associative property would be something like 3 plus 4 inside of parentheses and then adding a 6 to that. I'm telling you that it is the same thing as doing your 3 and then adding in parentheses your 4 plus 6. So if we work on the left-hand side, I get 3 plus 4, which is 7, plus 6. Now if I look on the right-hand side, I get my 3 plus, now in the parentheses, I have 4 plus 6, which is 10. Now working on the left-hand side again, 7 plus 6 is 13. And if you look on the right-hand side, I get 13. So if you notice, it's okay. It worked. The fact that my parentheses moved and grouped together two different numbers, it didn't matter because order doesn't matter as long as they're all positive, as long as it's all addition. Okay, so an example of this for multiplication would be similar to doing in parentheses 2. Let's do our multiplication symbol here. In parentheses, if we have 2 times 3, close our parentheses, and we're going to multiply that with a 4. I'm telling you that it is the exact same thing as doing 2 times, in parentheses, 3 times 4. So on the left-hand side, you would look in your parentheses and you would see 2 times 3, and you would get 6 times 4. And then on your right-hand side, always following order of operations, we would do our 3 times our 4, and we would get 12. And then I have my 2 right here. Well, on the left-hand side, if you do 6 times 4, you get 24. On the right-hand side, if you do 2 times 12, you also get 24. So the associative property states that when adding or multiplying, order does not matter. And those examples right there should help prove that. Okay, so let's delete that and switch to red and look at the commutative. Okay, so I think it's easier for me to say commutative. The commutative property states that when adding or multiplying, order does not matter. So you kind of notice a trend here that it's specifically when you're multiplying or whenever you're adding. So it applies here as well for the commutative rule. It's stating that if you add together A plus B, it's the same thing as adding together B plus A. You see how they kind of switch positions? You can do that. And then it's the same thing also if you multiply A times B, and if you were to multiply B times A. When I think of the commutative property, I think of commuting to work and how you start at home and then you drive to work. It's a very similar drive when you leave work and you come home. I just think of moving. And if you notice that A switched and it moved to the right-hand side, and the B was on the right-hand side and it moved to the left-hand side. So an example of this would be if I do 8. If I do my 8 times 6, I'm going to get, oh, you know what? I started with the addition last time, so let me start with the addition this time. If I do 5 plus 7, I'm telling you that's the same thing as 7 plus 5. Left-hand side, I get 12. Right-hand side, also 12. So that worked. Now if I do the multiplication, say I have 8 times 6, I'm telling you that that is the same thing as doing 6 times 8. Now, if you do 8 times 6 on the left-hand side, you get 48. And then if you do 6 times 8 on the right-hand side, you get 48. That may seem familiar to you because you logically could look at this and be like, yeah, of course it's going to equal the same thing. Actually, what you're doing is the commutative or commutative property. It's just not used to probably calling it that. But as long as it is addition or multiplication, your order does not matter. They can move positions and you'll still get the same answer. Okay. So let's delete that. And now let's look at our distributive property. The distributive property, or you'll hear me say like distribution, is when you're multiplying the sum of 2 or more by a number. I think I left a word out there. Multiplying the sum of 2 or more by a number will give same result as multiplying individually. Okay. And if you notice here, I have A times, and then in the parentheses, I have B plus C. So read that again. Multiplying the sum of 2. That's that B plus C, right? 2 or more numbers. And multiplying the sum of 2. That A is what's multiplying the sum of B plus C, because the sum is going to be the product that you get, it's the answer that you get when you add things together, right? If you notice on the right-hand side, it actually looks as if both of those individual terms, B and C, are being multiplied by my A. And the distributive property just states that if you multiply them individually, or if you multiply them after taking the sum of what's inside of the parentheses, you'll get the same answer. Okay, so an example of that would be, say we have 2, and then in parentheses, we have 3 plus 4, close parentheses. I'm telling you that it's the same as, I'm going to work on both sides differently, okay? Following order of operations, I've always said to solve what's inside of the parentheses first and then do your multiplication. This rule kind of teaches you a different way to do it, and it's going to be really, really important whenever we start 9.8 because we're going to introduce variables, and the distribution property is going to be used a lot in 9.8. So on the left-hand side, what I'm going to do is I'm going to take the sum of the two numbers that are inside of my parentheses. What I mean by that, taking the sums, I'm going to add them together. Now on the right-hand side, I'm going to follow the rule that I have right there, which is actually, this is the distribution rule. Okay, so this is like following the order of operations that we've been doing, which is solve what's inside of the parentheses and then do your multiplication. 2 times 7 would be 14, right? Now on this right-hand side, I want to show you this distributive law. Distributive law. Okay, so it was telling me that I could actually multiply them individually and that I'd still get the same answer. What this means is you actually are going to, that's how I'll show it in the work. Now, when I think of distributive, I honestly can't help but think of Amazon and how they distribute packages to people. So if you notice, Amazon is the number 2. It has things that number 3 and number 4 ordered, and it's actually going to distribute it to 3 and 4. 3 and 4 are both going to get multiplied by 2. So over here I have AB plus AC. And what that means is you take your, am I still blue? No, I'm green. You take your 2, follow that first blue arrow, and you're going to multiply it to your 3. When we do distribution, what we're doing is multiplying. And then I have my plus sign, follow that longer blue arrow. What you do is you take your 2 and you multiply it to your 4. So if you notice on the left-hand side, I took the sum and then I did the multiplication. On the right-hand side, I'm multiplying it individually. Okay, so if you look at 2 times 3, you get 6. And then if you look at 2 times 4, you get 8. Signs are the same, so it's positive. This one needs an extra line on the right-hand side. If you combine 6 plus 8, what you get is 14. And if you notice here, those are both the same answers. So that is an example of how you can take the sum and then do the multiplication, or you would individually multiply. In 9.8, the right-hand side is going to be what we really start doing a lot more than we have in the past. Okay, so let's talk about an additive inverse. An additive inverse is a number that when added to another number results in 0. I've always used money as an example for additive inverses. If I'm going to get to 0, I like to think of it as I have, $5 in my bank. What would get me to 0? Well, if I spent that $5, I would definitely get to 0. So that would mean that I was subtracting 5 from my total. So let me go ahead and do the example here. If I had $5 in my bank and what I did to it was subtracted $5, what I end up getting is $0. And yes, you're right. If you saw what I did, this is the same thing as this. As far as it being the additive inverse, that's why I did the plus sign, because I'm adding a -5 to my +5. But if you're asked, what is the additive inverse of 5? The answer is your -5, because that's the number that I used to get my other number to go right here to 0. Okay, so I want to actually do another one of those without all the extra going on there. This could probably be how you see it in the homework. It would say, like, we have a 4 plus, and then it might ask you. So this kind of follows the definition a little bit more. This is a number that when added to another number results in 0. So my question is, what goes in the blank? What added to 4 would get me to 0? Think about it, it's going to be the same exact number, but with a different sign. So if we had this example, I have a -5 and I need to know what gets me to 0. Just think of money again. I have -$5 in my bank and I don't want to be negative, so I need to add at least $5. That would get me to 0. Okay, so an additive inverse is a number that adds to another one, and it makes it cancel. That's what the word inverse means. Okay. Again, this is very super important stuff once we start 9.8. Okay, last property. We have the multiplicative inverse. So it's similar to the additive inverse, The additive inverse, we want to get to 0. For the multiplicative inverse, what we have is a number that when multiplied to another number results in 1. So an example of this would be if we have the number 5 and it wants to know what would I multiply to 5, and it told me it results in the number 1. So it wants to know what would I multiply to 5 to get 1. Well, I couldn't multiply it by 5, right, because that would just be 25. I couldn't do a negative 5 because now I've got a negative 25. Couldn't do 0. If I do 1, well, 5 times 1 is 5. Do you notice how my whole numbers aren't really working here? So what I need to do is think of something that the product is going to give me 1. If you look at the definition, I have A as just any number, and what I'm multiplying it by is this 1 over A. So that's telling me if I have a whole number, what I do is I actually put the whole number in the denominator under the number 1. 5 times 1 over 5 equals 1. And I'm going to show you how. Say we have 5. Actually, let me just delete this one right here. Whoop, don't know what that was. Let me delete this right there. Say we have 5 times 1 over 5. Do you agree with me that all numbers can be written over 1, right? It doesn't change it mathematically. So now I have 5 over 1 times 1 over 5. Well, I learned in 2.5 that if I have something in the numerator and I have something in the denominator and they have a common factor, they can actually cancel each other or like reduce each other. And I know that 5 and 5 have a common factor of 5. So if I divide 5 by 5, I would get the number 1. And then same here, if I divide 5 by 5, I would get the number 1. So what I have here is 1 over 1 times 1 over 1, which is what? Just 1. So what we did right here, when we did 1 over 5, that right there is called a reciprocal. I can't spell. Reciprocal. That is a reciprocal. Like I said, it can be written over 1. And then what I did was I just kind of flipped it, right? Okay. And we also learned that in 2.7 because we couldn't divide by fractions, right? We had to keep, change, flip. And what I meant by flip was use the reciprocal. Same thing right here. Now let me show you if we have, because that was a whole number. The reciprocal of a whole number is going to be a fraction, right? What if we have the number, if we have 5 over 6 and it wants to know what can I multiply to 5 over 6 to get 1? Well, I need everything to cancel, which means I need the same thing on the top that I need on the bottom, and I need the same thing on the bottom that I need on the top. So, same thing. You use the reciprocal and you'll get 1. One more example. Say I have a negative 4 over 5. What would get me to 1? Well, same train of thought, right? I know I need to go ahead and take the reciprocal because that multiplication, that multiplication is going to give me 1. But look at these two fractions. If you multiply a negative times a positive, you don't get a negative 1. You'd get I'm sorry, I said that wrong. You don't get a positive 1. You get a negative 1, right? So in order for this to be a positive 1, these signs have to be the same. So not only do you use the reciprocal, you also have to make sure you use the same sign. Additive inverse, same number, different sign. Multiplicative, it's a hard word. Multiplicative inverse is reciprocal, same sign. Okay, so I think that's it for now. I'm going to do another video later that will help you solve the remainder of 9.7 homework. There's an actual table that asks you for the inverses and a fraction problem that I want to look at. So if y'all have any questions, make sure you let me know. Thanks. Bye.